Okay, good morning. In the previous lecture, we have solved two numerical problems. Let us discuss the next one today. Uh, we will try to solve a few more numerical problems only related to different concepts on psychometry. The statement of problem is moist air at 40 degrees Celsius, comma, 30% relative humidity and standard atmospheric pressure flows at the rate of 10 kg per second through an insulated duct. Water at 20 degrees Celsius is sprayed at the rate of 0.05 kg per second. We have to find the outlet air state if all the water evaporates. Okay, so it means that what we have moist air, and this is at under which condition? 40 degrees Celsius temperature and 30% relative humidity, and what else? Atmospheric pressure. Okay, now this is passing through an insulated duct, so the chamber in which it is passing, it is insulated. Other than that, what we have done, we have added water over here. And what is the rate at which we are adding water? 10 sorry uh, 0.05 kg per second, whereas mass flow rate of dry air is 10 kg per second. Okay, so that is the given condition. And what we need to do now, it is also mentioned that what we are adding, you have to remember water, and this water we are adding at which temperature? 20 degrees Celsius. It means we are adding water to this air in the liquid state. Is this point clear? Whatever water we are adding in the liquid state because it is at 20 degrees Celsius. And one necessary condition is given in the question that whatever the water we have sprayed at 20 degrees Celsius at the rate of 0.05 per second, this water is completely evaporating. Okay, is this point clear? So all the water is basically evaporating, and in the vapor state it is mixing with the air. Is this point clear? So it means ultimately the heat from the air is utilized to evaporate the water. Is this point clear? Then what we, because duct is insulated, so there is no external heat which is coming, so it means heat from the air is only required to evaporate the water. Then we have to find the outlet state. Okay, how to start the problem? Now you should tell me the steps. First, can you represent this process on psychometric chart? Because if you can represent hypothetically the process on psychometric chart, then it becomes easy to follow the solution. Okay, so what will be happening in this process? What will happen? We are adding water. So if we are adding water, it means humidity must increase. So in between state 1 and state 2 will be having high humidity. And other than that, what about temperature? Temperature will be higher or lower? If you see, we are spraying water in the liquid state. Duct is perfectly insulated, no heat we are adding, and water in the liquid state is completely evaporating. So it means it is taking some amount of heat from the air. So if it is taking heat from the air, then it means temperature will drop, because air will lose heat in the form of sensible, whereas water will gain in the form of latent heat. So if it is gaining in the form of latent heat, it will not cause any temperature change. On the other hand, losing part is in the sensible form, so it will lead to decrease in temperature. So hypothetically, if I represent this is my state 1, then my state 2 will be high humidity. It means above than this, but temperature will be low, so it means towards left. So something like this. This will be my 1 to 2 process. Okay, is this point clear? Now of course, if you are using the psychometric chart, then Ambient pressure, relative humidity, temperature is given. You can easily locate state 1. For state 2, you have to do some calculations. After that only you can locate it. Because for state 2, I know only the two conditions, 20 degrees Celsius and ambient pressure. I don't know about third property. So that's why at present state 2 cannot be located. However, if we don't use psychrometric chart, if we have to only use the formulations, then how I can calculate humidity at point 1? Please tell me. If I need to calculate W1, how I can calculate? Yesterday also I have explained. Phi is 0.3 and at 40 degrees Celsius from the steam table I can calculate saturation pressure at this one from the steam table. Okay, and this is coming out to be 0.0738. If this is known, then W1 will become equal to, tell me, 0.622 phi PWS upon P minus phi PWS. If you calculate W1, then how much it is? How to calculate enthalpy? .0139. Okay. Now, what will be enthalpy? Please tell me. You must tell me now. Okay. Calculate the value. Calculate the value and let me know what will be enthalpy. Please tell me.
76. 75.9.
75.97 kilojoule per kg A. Okay. After this, for this process, it is given to me that this is the rate at which water is added. Correct? And it is also given in the question that all the water, whatever we are adding in the liquid state, entire water is evaporating. It means if all the water is evaporating, entire water in the vapor state is getting mixed with the air. So, I can say that mass of water vapor at outlet in the air will be m dot A2 into W2. Of course, m dot A only let me write because same dry air mass flow rate I am having. And mass of water vapor at inlet will be this one, and that must be equal to the amount of water added because all the water is evaporating. So it must be equal to m dot W. So from here m dot A into W2 minus W1 is becoming m dot W. We know all the three values. I can calculate W2. How much is W2 from this formula? Please tell me the value for W2. How much is W2?
0.018.
0.0189. Yeah, kgw upon kga. Okay. Now, if you see this process from 1 to 2, for this type of process from energy analysis already we have derived one equation for humidification process. If we add the water, what was the equation? Can you tell me? 1.005 into T2, sorry, not T2 even. Final equation was 1.005 plus W2 minus W1, correct? Am I writing correct or wrong? No, that is also wrong, sorry. This one into T2 minus T1 equal to, what was there? Please tell me. I have given you one equation where we discussed three cases. HW equal to
W2
HGT1, HW greater than HGT1, less than HGT1. So that equation I am asking.
W2 minus W1
W2 minus W1, tell me.
into HW minus HGT1.
HW minus
HGT1.
HGT1. What is HGT1? Simply H1 in our case. Just now I have calculated it as a H1. What will be HW?
HF 40 20
HW will be HF at
20
20 degrees Celsius. Okay, which will be 4.187 into 20. It is in the liquid state. So if 0 is reference state already for moist air properties, then 20 into 4.187, how much it is coming? Please tell me. Tell me the numbers.
83.9.
83.74 kilojoule per kg. This is kilojoule per kg. Okay. Now, after this, what I will be getting? Please tell me. I know HW. I know H1, W2, W1. I know T1. Can I calculate T2? Substitute in this equation and tell me the value of T2. What will be value of T2? Please do it fast. .04, correct. So this is the answer. Anyone is having any doubt about this question? Fine. Shall we move ahead? Problem number 4. Moist air enters an insulated duct at the rate of 10 kgA per second at 20 degrees Celsius and 50% relative humidity. So 10 kgA per second, 20 degrees Celsius, 50% RH. This is the entry state. And standard atmospheric pressure, PATM. So for all our problems, we will be referring to standard atmospheric pressure. Okay. And if it is heated by a heater of 25 kilowatt capacity, so we are adding heat at the capacity at the rate of 25 kilowatt, and steam we are adding at the rate of 0.1 kg per second. So we are now adding steam. What is the rate? 0.1 kg per second, and at what temperature? 100 degrees Celsius. Okay. So similar to the previous problem, but what two additions are there? Now instead of liquid water we are adding steam, and second important point is we are also heating. Heat is also being added. Okay, and we have to find the outlet state and the sensible and latent heat transfer rates. So outlet state and sensible and latent heat transfer rates. What will be the solution step? Tell me. You should be able to tell. First, at 20 degrees Celsius, I must calculate value of PWS, which will be P sat at 20 degrees Celsius. Already I have given in the previous problem. Given or not?
40.
Okay, that was for 40. Let me give it. 0.023389. What else? Anything else is needed? Not now. From here, if I calculate W1, it comes out to be, quickly calculate and tell me. Whatever this value we are calculating, if I use psychrometric chart, by just locating the state immediately I can obtain this value. Okay, from the chart itself. Because for inlet state always the 3 state points are given. How much is value? 0.00726. Okay, correct. What will be enthalpy? Please tell me now, you must tell me. How much is enthalpy? Tell me the value. You should be quick now. Whatever will be your speed, that will be deciding how many numericals we will be able to do. So if we are doing more numericals, we will be doing more practice. 38.5? 528, correct. Because I have kept only this session for numericals, next session we will discuss other concepts. So let's try to do as many numericals as possible. H1 is done. What should be the next step? How to calculate W2? Very easy. W2 is only coming from the steam rate. So m dot A into W2 minus W1 will be equal to m dot S. Okay. Tell me W2 how much it is? Whatever the change in vapor content, that must be equal to the rate at which steam is supplied. Zero point W2, yeah, 0.017, correct. Okay, what else? We need to apply energy balance. Huh? As per energy balance, what I will be having? M dot A into H2 minus H1 is change in enthalpy. That must be equal to amount of heat added due to the heater, which is Q at 25 kilowatt, plus whatever enthalpy steam is carrying, so that is m dot S into Hs. Now how to calculate Hs? Hg at 100 degrees Celsius. Okay, so Hs will be nothing but equal to Hg at 100 degrees Celsius, and the number is, what is the value? You must bring steam tables. Two six seven 5.44 kilojoule per kg. Okay, all of you must bring the steam table, and you should, whenever I am writing different steps, you should write, otherwise you will not be able to recall. From here what I can calculate? How much it is?
67.78.
67.78, correct. From this what I can calculate?
T.
T, calculate it. So you have come without any notebook. For how long this paper will stay with you? How much is T2? What is the value for T2? Please tell me.
23.7.
23.7. 23.737. Okay. Now, what else I need to calculate? I need to calculate total load, sensible load, and latent load. So, how much will be total load? M dot A into
H2 minus H1.
H2 minus H1. Tell me how much it is.
To 92.5.
292.5 kilowatt. Yeah, correct. What will be sensible load? That is interesting. Tell me. How much will be sensible load? M dot A, T2 minus T1. Anything else? Anything else? When we do M dot A into Cp, one more parameter also comes. What is that parameter? Enthalpy is equal to mass into specific heat into temperature change. What will be specific heat? Cp of moist air. What is Cp of moist air? 1.005
Plus 1.881 W2.
plus 1.88 into W1. This is Cp. How much it is? See, if I go to psychrometric chart, then what will be happening? I can draw one vertical line, one horizontal line. Huh? This will be intersecting at point 3. So process 1 to 3, if I know the enthalpy, then H1 minus H3 will be my sensible load and H2 minus H3 will be my latent load. Now in this direction what is happening? Only temperature is changing. So that's why m dot A into T2 minus T1. But for writing this change in temperature, we must have change in we must have specific heat. Okay, is this one clear? So this is my Cp value. Okay, tell me what is the value for sensible heat load? Deepak, what is the value?
Sorry.
So you are doing calculations in mind. What will be approximate value?
.03.
38.03. Is it correct, Deepak? Those who calculated sensible, they go for latent. 38.
254.47.
38.0.
6.
38.0672. Correct.
38.0669.
Now calculate latent heat. How to calculate latent?
Total minus sensible.
Total minus sensible.
2.
Otherwise,
M dot E into H2 minus H3.
m dot A into H2 minus H3. How to determine that? How to calculate H3? Chart say. If chart is not given, then what will be latent load? M dot A into, tell me, W2 minus W1, that is the amount of water vapor added. And what is enthalpy? Tell me, what will be enthalpy? What will be enthalpy? Latent heat of vaporization. How much is that? 2500. What approximation we are doing here? After conversion into steam, okay, in this water content, we are not including the sensible portion in the superheating. 1.88 into T. That we have neglected. Okay. So from here also you can calculate from this formula and tell me how much it is. You have forgotten when I explained you combined heating and cooling process. We derived one formula 50 into volume flow rate in cmm times W minus W2 minus W1. Okay. So there, what from where that 50 was coming? So 50 was basically coming from when 2500 divided by 60 multiplied by 1.2. Okay, from there.
254.46.
Is it matching with the previous value? Is it matching with total minus sensible? Matching? Okay. Let's then go for next problem. Problem number 5. Moist air enters an insulated duct at the rate of 10 kGa per second at 10 degrees Celsius and 40% RH P ambient pressure. Okay. Steam is injected into the duct at the rate of 0.3 kg per second at 100 degrees Celsius. We have to find the outlet state of moist air. Very simple question. Exactly the same question. Do it. What value you want, and even you need not to calculate even the humidity, because humidity initial state is as that of the second problem I discussed yesterday. So tell me W1. In the second problem I discussed yesterday, what was the W1? Quickly tell me. Yes, 0.00. So that is your humidity. How much was H1? 17.68. Okay. Now, is there anything to do in this question? Anything left, or it is easy now? What you can simply do? M dot A into equal to, tell me W2. Tell me W2. Zero point zero 3303. What about enthalpy? How to determine enthalpy? Again the same equation what I discussed in the previous question. What is equation? 1.005 plus 1.88 into W2 into T2 minus equal to W2 minus W1 into HW minus H1, and HW is nothing but Hg at 100 degrees Celsius. Previously I have given. Tell me the value of temperature. What is the value of temperature? Please do it quickly. You should be quick. Fourteen point 39 degrees Celsius. Okay. Question done. That is only were asked in the question. To calculate outlet state, so we determined W2, we determined T2. Okay.
सर
Yes.
वो प्रॉब्लम 4 में आपने H2 से T2 कैलकुलेट किया था प्रॉब्लम 4 में
No. From this equation. Yeah, in 3 I have calculated, in 4 from H2 only I calculated. Yeah.
That's the previous.
H2 can be written as 1.005 T2 plus W2 into 2500 plus 1.88 T2 from here also. Okay, all are done. Any issue in this question? No issue. Now let's see the twist. So if we see, it appears very fine. Okay, it appears very fine that we have calculated W2 and we have calculated the temperature. But now if you go to saturated state and try to calculate the saturated specific humidity at 14.39 degrees Celsius, its value is 0.01028. What it means? Yes. Okay. So at present this question appears from mathematical analysis, it is satisfying mass balance for water vapor, it is satisfying energy equation, and it is giving us the value of W2 and T2. Okay. But as a check, whatever temperature we are getting, corresponding to that temperature, air will be having certain capacity to hold moisture. So beyond that value it cannot hold the moisture. So what we did, we went to psychrometric chart, and from the psychrometric chart at 14.39 degrees Celsius I went to saturated curve. Saturated curve will be representing the 100% relative humidity, and corresponding to that I checked the value of W, that has become WS. Is this point clear? And when I observe the value of WS, it is 0.1028, and WS is basically less in comparison to W2, which is 0.03303. It means that the outlet humidity, whatever we are calculating, that is even greater than saturated air. But air cannot hold moisture above than the saturated condition. So it means that remaining portion should be now condensing, and that condensate must be present in the form of fog droplets. So how much will be the mass of condensate in this? Mass of condensate must be equal to m dot A into W2 minus WS. Is this one clear? Because at temperature 14.32, maximum amount of humidity possible will be WS, if same is the temperature. Then the amount of condensate in this should be equal to this value. Is this point clear or not?
तो ये बाकी क्वेश्चन जो भी चेक करना पड़ेगा.
Yes. But again the catch is, now I am assuming that it is 14.39. But answer, will my answer be 14.39? Because I am adding steam. When this steam is converting, part of steam is converting into liquid, it must also release latent heat of vaporization. So it means T2 should also not be same. So I cannot directly say that condensate will be m dot A into W2 minus WS. Again some catch in the question. Okay. So how to do this now? Think about this. How we can do this? Please tell me how to do this.
WS given
But how to determine WS? Because temperature will not be 14. Okay? Temperature can be anything. First we need to write energy balance. And energy balance we need to write meticulously. How we can write energy balance? M dot A into H2 minus H1. That is very clear. For moist air, that will be the change in enthalpy. And this change in enthalpy will be equal to first the amount of steam added, m dot s, into enthalpy of steam. That is correct. However, out of this steam, some amount has condensed in the form of condensate. So minus m dot of condensate into this condensate will be present in the form of which state? Liquid state. So it must have its HF. And let us assume that HF is at temperature of moist air only. So liquid droplet is also in thermal equilibrium with the moist air. Correct? Have I written correct energy balance?
यहाँ से m dot c निकालेंगे.
You see what you can calculate. M dot A is known, H is known, this is known, this is known. However, now there are three unknowns. First is H2. For calculating H2, we must know something. HF is unknown because HF is corresponding to final state temperature, which is not known. And M dot C is mass of condensate, which must be equal to m dot A into W2 minus WSF. And WSF is again a function of temperature. So here HF is function of T2, H2 is function of T2, and this previous equation where I need Ws, that Ws is also function of T2. So it means that if I give a guess to T2 value, with that guessed value of T2, I can calculate HF, H2 and Ws. Is this point clear? With guessed value, I can easily calculate H2 from the equation. I can, and how from equation? Because I will be knowing Ws from the psychrometric chart. Okay, for saturated state. Correct or not? Correct? Even I need not to use psychrometric chart, I can directly calculate from the formula also. What will be Ws? 0.622 into PWS at T2 divided by P minus PWS at T2. Why I have not taken phi? Because phi is 100% saturated state. Okay? Correct? So, what should I assume the value of T2? Let me assume in first trial that T2 is 30 degrees Celsius. If I use T2 is 30 degrees Celsius, then I get the value of Ws as 0.027392. Value of Hs is, I think, already known to us, 100, and value of HF as 125. Is this one clear? What is Hs? Sorry, this is H2. Yeah, H2 is 100. Now what I need to do? Now what I need to do, please tell me.
m dot c. दोनों इक्वेशन से m dot c.
What was the initial value? You tell me. 10 degrees Celsius. What we have added? Steam. Steam we have added. So whenever we are adding steam, its enthalpy will always be greater than the enthalpy of the moist air. It means heating is taking place. Parallelly, we are also assuming that some part of steam is condensing in liquid droplet. So that is also releasing latent heat of vaporization. So that's why amount of energy released is significant. So that's why a slightly higher value I am assuming. Okay. Of course, it will be random. First trial will be always random. Okay. So if you do this, how to now proceed further? Please tell me. First, I will be solving this equation. Equation number 1. From this, I will calculate m dot c. Then I will be substituting in this equation and I will be calculating LHS and RHS of 2. So LHS of 2 is how much? LHS of 2 comes out to be 823.31. Correct? And RHS of 2 is how much? 795.539. So LHS is not equal to RHS. It means our assumed value of T is not correct. What I need to do then? Second trial, decrease because RHS is more. So what I have assumed T2 is 29 degrees Celsius. When I went with 29 degrees Celsius, again I find 793.76 and 771.95. Okay, so it has went in other way. Then what I have done, I have assumed temperature of 29.5 degrees Celsius. When I use 29.5 degrees Celsius, then my RHS is
सर लेकिन LHS तो अभी बढ़ा है ना 793 और RHS तो 7
but in left hand side also H2 is function of T2. So that part also we need to keep in mind. Okay. So at 29.5 it is 794.66 and LHS is how much? You will not be knowing. Let me tell you. 797.59. These are very close. So it means I will be assuming that T2 is 29.5 and corresponding to this, what is my humidity? W2 is Ws is equal to W2 is equal to 0.02656. You got the point how to apply trial and error method?
temperature 29.5 इसलिए है those are value decrease
Correct? Shall we go ahead with next problem? Next problem is for you. You can do it by your own. Let me explain the problem. Moist air enters a cooling coil at 40 degrees Celsius dBT. Remember, moist air where it is entering? It is entering a cooling coil at 40 degrees Celsius dBT and 50% RH and of course at ambient pressure. Okay. If it leaves the cooling coil as saturated air at 20 degrees Celsius. So exit state is saturated air at 20 degrees Celsius. This is the exit state. Okay. The condensate, okay. The condensate also leaves at 20 degrees Celsius. What it means? When this air is getting saturated, some amount of liquid is also forming. And whatever the condensate is forming, that condensate is also leaving the coil at 20 degrees Celsius. Is this one clear? What it means? The mass flow rate of air is 100 kGa per minute. It is 100 kGa per minute. We have to determine the condensate rate and cooling capacity in terms of refrigeration. So m dot C, the rate at which condensate is forming, and cooling capacity will be coming from total load, sensible plus latent load. So Q total, and this we have to find in tons of refrigeration. So let me explain you the representation of the problem. Problem is like this: you have a duct. In this duct there is some what? Cooling coil. So you can assume, say, some refrigerant is entering and then refrigerant is going out. So it means it is cooling. Then you have from here at m dot A moist air is entering. When this moist air will be on this, then at the exit moist air will be cooled, and upon cooling some amount of what will happen? Water will also form. Okay, because of the condensation process, whenever you cool in AC, then some water also forms. Because state 2 is saturated. So if state 2 is saturated, it means some condensate has also formed. It is given in the question that condensate is forming. And in the bottom we are collecting this condensate, and m dot C we are taking out at 20 degrees Celsius. This is also at 20 degrees Celsius. This is at 40 degrees Celsius and 50% RH. And m dot A is 100 kGa per minute. So this is the problem. You have to calculate condensate rate and tons of refrigeration. Tell me this in the next class. Other than that, I was having two problems on adiabatic mixing. Probably because already I discussed the trial and error method, how to apply. So fog formation related problems due to adiabatic mixing you can try by your own now. Okay? Is this point clear? All of you please solve the numerical problems.